Okay, we come to the final talk of this afternoon. So it's great to be able to introduce Michael Klemm. Michael is the CEO of the OpenMP Architecture Review Board. So is in charge of OpenMP and ensuring that it goes along and everyone's collaborating together on this open standard. So over to you, Michael, to tell us all about OpenMP 5.1.
All right, thank you. So one disclaimer I need to add is that I won't be able to tell everything about OpenMP 5.1 because it became a much bigger release than we initially anticipated. But anyways, I'll try to give a small glimpse at what OpenMP 5.1 is and what to expect in the future of OpenMP. All right, just a few words about the Architecture Review Board. So as you all should know, the OpenMP ARB is the body that owns OpenMP as a trademark and also owns the OpenMP specification. And the mission really is to standardize this directive-based multi-language programming model. We strive to have high-level parallelism. You've seen a couple of examples earlier today about this. Going from very high level Perl 4 type of programming down to very machine oriented programming. And we aim to be performance oriented and productive, as well as portable, and portable in the sense of functionality, not performance portable, of course. One thing I wanted to note is that the OpenMP API is usually not doing bleeding edge research standardization, but rather we consider common approaches the state of the art or the state of practice, as Jonas was calling it earlier today. So we standardize the common practice in the industry as an industry standard. And on the right-hand side of this slide, you see a couple of the logos of our members. So it kind of reads as the who's who of the HPC community. All right, in terms of roadmap, so as already has been mentioned today, we just released OpenMP 5.1 earlier around supercomputing timeframe, about 3 weeks ago, I think it was. So this is it's a minor release, but as I said, it became a little bigger than we initially thought. In November 21, we are aiming for an OpenMP 5.2 release. The reason for this release is going to be more structural changes than actual feature changes. We may add a few minor things or iron out a couple of bugs that we may have left in 5.1. But still, the idea is to just restructure the specification so that it becomes a bit more manageable and readable. And then in November 23, that's our usual 5-year cadence, we will have OpenMP 6. And in the meantime, we will show signs of life through what we call technical reports. So every year, also at around November timeframe, we release a technical report, which is kind of the current preview release of what will be coming, what we are talking about in the OpenMP language committee, so that the community can interact with us and tell us what they like and what they dislike in these technical reports. As I said, OpenMP 5.1 has been released, so you can download a PDF from openmp.org. That's our website. You can also browse an HTML version there, which is quite nice if you want to link to a particular OpenMP feature, or if you don't want to browse through an OpenMP PDF. And the other thing that we did is, starting with 5.0, I believe, we also started to publish the OpenMP specification as a printed book. For those old-fashioned guys like I'm one, I like to read in paper, so you don't have to print it yourself. You can just order it off Amazon. It's basically wholesale price, so I believe the US price for this book is like $16. I think it's 17 in Europe. It's basically the same PDF, just printed. All right, so OpenMP 5.1, just a kind of historic recap what happened in 2018. So OpenMP was potentially the biggest release that OpenMP has ever made, apart from, of course, the inaugurational release in '97. And so there's a whole bunch of features, some of which have been discussed already and presented today. But it was a pretty big release. And so our tools vendors and compiler vendors, they really need a little bit of time to breathe. And so we tried to keep OpenMP 5.1 a little smaller than we usually do. Regardless, we thought that we would add a couple of nice things to OpenMP 5.1 to make it more programmable and more useful to programmers. And so there's a bunch of things, and I'll pick some of them today. So for instance, there is C++20 support. Even though C++20 hasn't been released yet, we already anticipate that release, which is hopefully happening right now. And so we kind of prefetched that into OpenMP 5.1 so that a good share of OpenMP supports C++20 features. All right, let me give you a couple of new features. Certainly, I won't be able to cover everything that we did. And so this is kind of an arbitrary subset of things where I thought I'll just show what we did. All right, so Jeff Larkin already mentioned that in his presentation. The interaction with low-level libraries like CUDA, like OpenCL, or Level 0 in Intel's case, has been improved. With OpenMP 5, we actually did, we introduced interoperability in terms of what Jeff was showing, that you could get the buffer that is associated with some data management directive in OpenMP, get the low-level buffer object, like a CUDA buffer object, out of the OpenMP implementation and feed that into something like cuPLAS. And with the interop feature, what we did is you can now query additional information from the low-level implementation. And so one particular example where this is useful is now you can actually ask the OpenMP implementation to get out or give out the stream that is used to do the target offloading of the offload regions that you have in your code, and then you can use that stream object as part of something like a cuPLAS call to use that as the stream where the library should also send your request to, and you can use that to implement additional more low-level synchronization mechanisms, or use asynchronous offloading in those libraries, or whatever you're after, or get the events out of the streams, whatever. So this is one thing. Certainly, you will be less portable when you do these kind of things. But at least you can now, from OpenMP, interact with these low-level libraries if you wish so. One minor thing that we did is OpenMP 5.1 deprecated the master construct, and we replaced it with a more versatile and flexible construct. So instead of master, which basically just was syntactic sugar for, run this code on thread ID 0, so the main thread of your parallel region, you can now either get the same behavior by just using omp mask, or you can use the filter clause to give the mask construct a thread ID, and then the code that is associated with that construct here will run on that particular thread ID. And in the future, likely in OpenMP 6, we will extend the filter clause to allow more subsetting of thread teams, like every odd thread or every even number thread, or every thread that has a prime number as a thread ID. Or you can particularly construct a thread subset that you would like to have that code executed on. So this is something that has been long been asked for, and we finally found the time to do this and implement such a more versatile construct and replacement for master. The code construct is a construct that you can use inside a parallel region to create additional subscopes inside that parallel region. So what I'm doing here on that slide is I'm using the scope construct to implement a reduction across the parallel team, which pretty much was impossible in OpenMP until 5.0. And you had to, use pragmatic patterns like this, where you had to inject like a dummy for loop so that you could have a reduction clause inside a parallel region. And then, you would iterate across the thread IDs of your team, basically doing nothing. And so the scope construct is kind of a replacement and syntactic sugar for that pragmatic pattern. And in the future, this will also be extended to have more useful applications inside OpenMP. The other thing that we did with OpenMP 5.1 is we introduced the assumes directive. So in OpenMP 5.0, we already introduced the requires directive that Jeff mentioned briefly, where you can do things like requiring shared memory support between host and accelerated devices. And the assumes clause now gives a way to the programmer to tell the implementation that it may assume a certain program behavior, even though the OpenMP features hasn't been subsetted like it is done with the requires clause. So one thing that you can particularly do is you can, restrict the code or tell the compiler that the code will not encounter certain OpenMP constructs, or that it will contain certain constructs. You can give conditions like invariants, where you can say, assume that this condition holds, like, this number is always even, or that no OpenMP code will be executed, or that nobody calls an OpenMP API routine, or that no parallelism is created, so no OpenMP tasks and no SIMD execution is part of that code path where this assumes directive is valid for. Here's an example. So, if you have a function where you have a parallel region where there's guaranteed no tasking, you can tell the implementation that it may assume that the task and task wait constructs are absent from the code. And then inside that parallel region, the compiler can take these assumptions and, for instance, optimize the barrier and replace it with an implementation that does not support task completion versus the traditional regular barrier that has to support that. And so you can get a little bit better and more efficient barrier implementation than without this assumes. And so now the compiler could be able to take that into account and optimize the code accordingly. The other thing long discussed and finally been done, we now support C++ attribute syntax in OpenMP. It's actually a bigger feature than you would expect for OpenMP 5.1, but it wasn't ready in time for 5.0. So when you look at the C++ 11 proposal for attributes, they actually had an OpenMP example in there. And so, we are kind of good citizens by following their suggestion and implementing it. So instead of using, old style Pragma OpenMP 4 syntax or OpenMP syntax, you can now use these attributes to get a more C++y look of your code. Plus, C++ attributes are subject to template programming, so you can now use those within C++ templates, which is not possible with traditional pragmas and directives. And there's a particular Twitter reaction I wanted to share with you. So someone on Twitter really freaked out because finally we made this available, and he's really happy about this, and he's writing like, oh my god, instead of pragma, C++ attribute syntax can now be used. So that is something that makes OpenMP a little more accessible for C++ programmers. All right, in summary, so 5.1 and also 5.0 are a big and major leap forward for OpenMP. Probably these two releases are the biggest series of releases ever in the history of OpenMP. And so, they really introduced new ways to express parallelism. And we also improved the usage of existing features naturally. And hopefully you'll take away from what I just said is that OpenMP, despite that it can still use directive and pragma syntax, is a modern programming model with a lot of different ways to approach parallelism. So you can use coprocessors, accelerators, GPUs, FPGAs. We do have regular multi-threading support as well as SIMD. Task-based programming model, it already has been said earlier today, is kind of the modern approach to parallelism to fight Amdahl's law in a way different way. We have powerful language features to support complex algorithms, especially task dependencies, allow you to do a lot of things around modeling complex algorithms in terms of task parallel execution. And then the other thing, you can start easy with parallel 4, and then you have a path forward to highly efficient programming where you can control almost every bit of execution and how the implementation transforms your code. And with that, I'm done. If you want to know more, please visit our website, openmp.org. There's a ton of information, links to tutorials, links to collateral, links to tutorials, links to the specification naturally, and as well also use cases. So it's a good resource if you're really interested in what's going on with OpenMP these days. Thank you.
Thanks a lot, Michael. That was a bit of a whistle-stop tour of OpenMP 5.1. It's really great to see that. I think we'll move straight into the panel session now, and anyone who has any questions for Michael's going to be part of the panel, so we can direct the questions to him there. Thanks, Michael.